Welcome to the next lesson. I am going to show in this lesson how to graph things in a TI-83 calculator, as well as once they're graphed to find such features as x-intercepts, relative maximums and minimums, points of intersections between curves, and values on the curve, both in terms of given x values and given y values. We'll proceed by starting with clicking the y equals button to enter a function dialog here where we get to type things in, and I'm going to type in this blue function that you will see to the right labeled g of x. So one of the things that we'll need to of course practice is how to get such a data point or such a function in there when we don't have the nice beautiful notation that we typically see in a textbook. So because there are multiple things in the numerator and multiple things in the denominator, I will need to have parentheses around both my numerator and my denominator to make sure I'm dividing the entire thing. I can put those in advance as I just did here if I like. But if I do that, I need to understand that the calculator's native language is to type over top of what has been written in there. So if I would like to insert something, I need to hit second delete in order to reach the insert. The flashing cursor will now let me know that what I type will remain inside those parentheses. So I have 1/5 times x. X is this variable right here. It says xt theta n. This is our variable button. So x to the third power minus a 2 times x squared. There's an option for shorthand for square, plus 5. Then I could arrow over for the denominator. Again, I need to insert if I don't want to type over top of what I've typed. And then I have an x minus 4. Once I've got that, I can graph that and see what it looks like. The way the graph works in a Texas Instrument calculator is it essentially graphs 1,000 points or something like that and plays connect the dots. So when it runs into a vertical asymptote as we have here, it is simply finding a value for the function when x is really close to 4 but just shy of, like 3.99999, and then a value on the other side of 4 like 4.001, and it's playing connect the dots, and because of the pixelation it looks like a vertical line there, but it's actually drawing a slanted line to connect those two. So we need to be aware of that asymptotes can look that way. The only way to really be certain that that's an asymptote is to either understand the math that it's undefined at 4, or to rezoom this thing to look way down here off the edge of the graph and way up here off the edge of the graph to make sure that it doesn't in fact round over and maybe just drop like a rock before rounding over again. Anyways, let's proceed and see what other pieces we can find on this. If we go into the calculate menu, which is under second and trace, we can see all of the options of what we can calculate on a graphic. It has value, 0, minimum, maximum, intersections, all that sort of stuff. So we'll explore those one at a time. First with value. So if I hit enter on this to find a value, I can type in a value and see what comes back out. So I could explore that 0.4, for example. I suspect that there's a vertical asymptote there. In fact, I know it, but I could explore it, type that in, and it's not going to give me a y value because it's undefined. I could go in and try a different one. I could find a value of 5. Oops. Enter. I can find a value of 5. And it's going to tell me that I get a negative 20 back if I plug a 5 in. So I can do that as many times as I want and find those. The next thing that I could do is I could go second, calculate. The next item down is called 0. That is the more technical term for what we call an x-intercept. It's describing when the output of the function, the y value, is 0. So we can try that one out. So we hit enter. This one asks us 3 questions. It asks for a left bound, a right bound, and a guess. So first we need to arrow until we can see our cursor on the screen there. I'm going to go ahead and find this 0 that's looking like it's out there near 10. And I'm going to stay to the left of it and hit enter. Then I'm going to arrow to the right of it and hit enter. And then I'm going to backtrack and get a decent guess of where it's actually at and hit enter. And the computer will refine that guess using an algorithm and tell me that the answer should be 9.736 comma 0. So we can see that we are actually laying on the x-axis. So we could repeat that process and we could easily find the 0 over here and the 0 over here. And of course we need to understand that this vertical line that we're seeing, or seemingly vertical line, is in fact the vertical asymptote. So there is no 0 at 4. So that's another thing that we can do in there. Next on the list, we can look for minimums. So this particular graph does have a minimum, so we can find that. So we hit enter, and again we arrow till we get kind of proximate to it. There's only this one minimum right here that's very near to the y-intercept, but we don't know exactly whether it is the y-intercept or not. If we look at the better looking graph over here, it seems apparent that it's actually slightly to the right of the y-intercept. So again, it asks for left bound, a right bound, and a guess. And it tells me then that the minimum has a value of 0.344, comma 1 or negative 1.305. So I can definitely tell now that the minimum is actually not the same as the y-intercept, in spite of the fact that on the calculator's graphic interface it kind of looks like it might have been. So that's one of those things to be careful of. Don't assume anything. Okay, the last thing that we can do in here is we can find values for x going the other direction. Suppose we want to pick a value for y and figure out what x is supposed to be. We can go the other direction with that as well. It's a little more cumbersome, but it's pretty straightforward. We do that by finding a point of intersection. I'm going to go back to the y equals dialog. y2, I'm going to pick the value of y that I'd like to find. So maybe I'd like to determine what y values, or what x values I should expect when y is equal to 5. So we can hit enter and it'll give us the next one. We can graph it. It'll give us that extra line on there. We can see that the line y equals 5 intersects the graph in 3 locations. That means that there are 3 x values for which we can have a y value of 5. We can also see this on the nicer looking graph to the right. I've got my cursor right now at 5 for y, and it looks like the corresponding x value will be something like a negative 4. Then again it happens somewhere around 3, and then again it happens somewhere around 11. Again, I can't trust those for accuracy. I need to actually run the algorithms to test that. So again, I go back into that calculate menu. This time I'm going to go down to the 5th option, the intersect command. By the way, I can get that also by just clicking on the number 5. This time it asks me to locate the first curve and then the second curve and then a guess. If I'm finding an intersection, it's based on 2 curves, so I have to tell it which. So it's currently on the curve that's actually curved, not the horizontal line. But if I arrowed up or down, it's going to show me the different curves that I can choose from. And notice it actually gives the equation of those as well. So I'm going to let the curve be the first one. Enter. And if there's only 2 options, it automatically jumps to the second one. I hit enter again to select the horizontal line, and then enter a 3rd time to aim at which intersect I'd like. I'm going to go ahead and go for this one that's way over here, somewhere near 11, and see what it comes out as. And hit enter. So there's the actual reality of it. The x value is 11.2348 for the y value to be 5, as opposed to my guesstimate of 11. I just guessed that 11 looked pretty close, and it was pretty close, but it wasn't accurate. So I could repeat that process and I could find those other values of x for which y is equal to 5. The last thing I'll do on here is I'll go back into the y equals dialog and I will graph that second equation that you see to the right in red. That is an 8 times e to the, notice it gives an open parentheses here right away, e to the negative x squared over 8, all in the exponent. Well, we have a negative symbol rather than a subtraction symbol for negative, so I got to be careful I use this one down here and not the subtraction symbol in blue a little higher. So negative x squared divided by 8, and then I must close off my parentheses so I know that all that stuff is in the exponent. I can graph that, and then it gives me that bell curve as well. And I could find the point of intersection between those two values. I could figure out where this crossing point is right here. So to do that, again, second, calculate, 5 for intersect. Again, it asked me for which curve I want to use. So I can select my two curves. Doesn't matter what order I do this in. So first the rational one, then the exponential one. Get those two things. And then I can guess at that crossing point. It's close enough. Guess. And so it's telling me that this particular point where you see my cursor is x equals 5.28, or sorry, 2.585, and y is 3.469. So I can find that point of intersection. This becomes significant because that point of intersection, or that x value that goes with that point of intersection, would actually be the solution to the equation f of x equals g of x. So if somebody asked you to solve something that's as hideous as 8 times e to the negative x squared over 8 is equal to the rational expression with a numerator 1/5 x cubed minus 2x squared plus 5 and a denominator of x minus 4, algebraically, that's beyond our ken. We don't know how to do that. We can't deal with something that has both polynomial components and exponential components mixed together. So with the aid of some technology here, we can actually find the solution to that. We can find that point of intersection between those two, which would represent the x value of that equation. So thank you for listening. I hope that helps you get through your homework assignment. And with the second video, we should have everything that we need for that assignment. Thanks. Bye.